Hello everyone, we are at Beyond the Formula. Let's find out the distance between a point and a line in 3 dimensions. So we have a point, suppose this is the point A or say P, and this is a line in 3D. Let's say this is the line L, right? Now we need to calculate shortest distance between point P and line L, right? Now we know that the shortest distance will be what? Perpendicular to the line, right? This, let's say this point be Q. Now you see the equation of line in 3D, right? Let's memorize what was r vector equals a vector plus lambda times b vector, right? Where what was r vector? Position vector of general point, right? Position vector of general point on line, right? A vector was position vector of given point on line, given point on the line, right? And B vector was parallel vector to line, right? Similarly, in the Cartesian form, we have x minus x1 over a equals y minus y1 over b equals z minus z1 over c, right? Where x1, y1 and z1 were the coordinates of the given point, that is x1, y1, z1, and a, b, c were the direction ratios of vector b, right? Now we can use either of the form of the equation of the line. We will prefer Cartesian form, that is because it is easy to understand, right? So let's see here in the diagram we have the general point, right? We have general point, this r vector or this x, y and z are the coordinates of the general point, right? So general point can lie anywhere, right? This can be here, this can be here, this can be here, this can be here, this can also be this q, this can be here, anywhere, right? General point can be anywhere. Now for this general point we can calculate the coordinates of the general point in terms of lambda, right? So we have x1, x minus x1 over a equals lambda, right? Which gives x equals to what? x1 plus a lambda, y equals to y1 plus a lambda, and z equals b lambda, right? B lambda, and we have z equals z1 plus c lambda. Now this is the general coordinate. This is the general coordinate or coordinates of the general point, right? This can be coordinate of point A, this can be coordinate of point B, C, D, Q, E, and many other points. For this to be coordinate of A, the value of lambda can be something else, say lambda is equals to something alpha 1. For this to be coordinate of point B, lambda can be equals to alpha 2 and so on, right? Only changing the value of lambda, only changing the value of lambda, we can get the coordinate of every point on this line, correct? Now for this point, for this general point, right, for this general point to be the point Q, for this general point to be the point Q, what is the condition we have? We have PQ is perpendicular to L, right? So we have we have only one condition. We have PQ line perpendicular to line L, right? And we know that what B vector is parallel to line L, which implies that B vector is perpendicular to PQ line, right? Now, if B vector is perpendicular to line PQ, if B vector is perpendicular to PQ, that will imply what? That B vector dot PQ vector equals 0, because for two vectors to be perpendicular, their dot product will be 0, as cos theta cos 90 equals 0. Now we will use this equation now to get the direction ratio or this line PQ vector. To get PQ vector, we will do nothing but, to get PQ vector we use simply what? Position vector of Q minus position vector of P, right? Now we already know the coordinates of P, right? Because it will be given to us, right? Say suppose we have x2, y2, z2. This is the given point, right? And we will have x1, y1, z1 in the equation of the line. So we have position vector of Q, right? Q has the general coordinates x, y, z. Q has general coordinate x, y, z. So we have position vector of Q as PQ vector as x1 plus a lambda times minus x2 I cap plus x y1 plus b lambda minus y2 j cap plus z1 plus c lambda minus z2 k cap, right? This is PQ vector, right? So we used position vector of Q minus position vector of P. Now how do you write position vector? Nothing but use the coordinates, and x, with x coordinate you have I cap, similarly j cap and k cap. Now we have B vector as what? B vector as ai cap plus bj cap plus c k cap, right? Now we have PQ vector dot B vector equals 0, right? Now how do you take the dot product of two vectors? Just simply multiply the coefficients of I cap, j cap and k cap respectively, right? So we have PQ vector dot B vector as, now simply multiply. So we have a times x1 plus a lambda minus x2 plus b times y1 plus b lambda minus y2 plus c times z1 plus c lambda minus z2, and which is equal to 0, right? So we already have a, we have values of x1, y1, z1 and x2, y2, z2, right? And a, b, c, right? Because this is the point, this is point P, this is the given point, say suppose A, and this is the B vector, right? So these all the things will be given to us in the questions, right? So we have a, x1, x2, b, y1, y2, c, z1, z2, and only remaining thing will be lambda, and from this equation value of lambda can be calculated, right? Now we will get the value of lambda for which the general point, this general point Q, this general point Q will be perpendicular to the line, that is the PQ line will be perpendicular to line L. When you get the value of lambda, suppose for example we have lambda equals 1 and x1 y1 z1 equals say 1 2 and 3, and say x2 y2 z2 equals 1 minus 1 2, and we have suppose a comma b comma c as 1 comma 1 comma 2, right? So now let's calculate what? Let's calculate the coordinate, right? So here we have general coordinate x as x1 plus a lambda, right? So we have x1 as 1 plus a as 1 and lambda as 1, so we have value of x as 2. Similarly y as y1 plus b lambda, so we have y1 as 2 plus b as 1 and lambda as 1, so we have 3, and z as z1 plus c lambda, so that is z1 as 3 plus c times, so c is 2 times lambda is 1, so 3 plus 2 5. So we have the coordinates of the point Q as 2 comma 3 comma 5, right? This is point Q, and we already have coordinates of point P, that is x2 y2 z2, that is 1 minus 1 and 2. Now we can easily calculate the distance d using distance formula, right? So we will not calculate here, that was just an example. You can easily calculate the distance using the distance formula, that is what? x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square equals d, right? We have x1 y1 z1 and x2 y2 z2. Thanks.